Okay, good morning. So the next part of the lesson in Math 4 is very famous formulas in trigonometry called addition and subtraction formulas. Okay, so to motivate you this about the formulas. So one, I don't know, common mistake, I also saw it in your solutions when you were solving that quiz problem, that you have this idea somehow, which is a common mistake. I don't know where is it coming from. So if you have sine of alpha plus sine of beta, I don't know, some people write it as sine alpha plus beta. Okay, I still don't understand exactly where is the source of this error, but the point is probably you are thinking sin as some independent entity so that you can pull it out. So might be in your head you are comparing it with this situation. Yes. In that situation, of course, I can pull A out and write alpha plus beta. But this is completely different from this scenario, yes? Because sin, you cannot just write sin, even though some people for laziness just write sin. Be careful, in the exam you have to write it completely. Sin doesn't have any meaning at all here, yes? Unless you put a number, you put an angle in front of it, and when you put an angle in front of it, then the whole package becomes one single number. So sine is not something, alpha is something separate, so that you can pull sine out from here, okay? So I don't know, I have seen this is a very common mistake when I'm teaching, but hopefully I could explain you what is the difference. So at least it might be true or might be false. Yes, I'm not saying that this is 100% wrong, but if you don't have any reason to write it, either you have to first prove it or don't use it at all. Okay, so is that clear first? Okay, and then I want to tell you that this is really wrong. Okay, this is not a formula that you can rely on. Why is that? For example, if this is supposed to be a formula, so it means that I should be able to rely on it for all possible values of alpha and beta, yes? But let us, for example, be a little bit clear here. So let me choose alpha to be 30 degrees, and let me choose beta to be 60 degrees, yes? And then what happens? Let me calculate the left-hand side, which is sine 30 degrees plus sine 60 degrees. Okay, and then if I take the table, sine 30, I have it in my memory, it's 1/2. Sine 60 is the square root of 3/2. If you want, you can take the common denominator, so this becomes 1 plus square root of 3. Yes, this is what left-hand side is. But what is the meaning of right-hand side? Okay, the right-hand side, I have a pair of brackets and I have an operation inside it. Pair of brackets prioritize that operation first. And then after this is done, I apply sine on it. So if you want to calculate this, you have to wait. Instead of alpha, you put 30. Instead of beta, you put 60. And if I ask you to calculate this, again, I am just emphasizing, don't think that you can write sine this plus sine that. This means first do this operation. So when you do that operation, you get 90 degrees. And after you found the answer to this, then sine will apply on it, yes? And if you see the table, sine of 90 degrees is 1. So the left-hand side is such number, and the right-hand side is 1. At least this example shows that this is not a reliable formula, yes? Because at least for this case, the left-hand side and the right-hand side does not match. They don't match, yes? So don't do these mistakes. So let me just cross it over. So if you think you might make the same mistake again, write it down somewhere and cross it over. So this is not the general formula. Okay, so we want to understand now, how can I write something about it? For example, the question is that if I give you alpha and beta, and I ask you to calculate this, this is a very simple task. You even don't need any lessons. If I give you alpha, if I give you beta, and if I ask you to calculate this, what you're supposed to do, you need to add those angles first and then type sine. Okay, so even if you want to type it in your calculator or your computer, you have to write sine of that angle plus that angle. So if someone asks you what is the meaning of this symbol means first add the angles, it becomes a new angle, and from that new angle you calculate sine, it becomes a number. Okay, so this is the meaning of this symbol. Similarly, the meaning of all other symbols, for example, I can talk about cosine alpha plus beta. I can also talk about sine alpha minus beta, and I can talk about cosine alpha minus beta. So none of them can be done in this way. So for example, for sine alpha minus beta, you are not allowed to write sine alpha minus sine beta. Okay? Okay, so this problem is very easy if I give you the angles. Okay, if I give you the angles, you do this operation first. If it is sine, you take sine. If it is cosine, you take cosine. But the question is that, in general, is there any relation between this number and sine alpha and sine beta? This is a natural question. I would say that because this is sine of alpha plus beta, can I discover a formula in general that relates this quantity to these two quantities, or in terms of alpha and beta? Okay, so the question is that if I give you sine of alpha and sine of beta, can you calculate sine alpha plus beta without knowing the angles, just knowing sine alpha and sine beta? Okay, so this is the motivation behind this lesson. And there are 4 formulas, all of them will be given to you in the formula sheet. But you need to really understand the problem and need to know how to use them. Of course, I will do the proof here for you if you are interested to see where the formulas are coming from. But usually that is not what is demanded for the exam. But it is better to see where these formulas are coming from. Any questions? Yeah? So for example, another common mistake is when people write sine 2x, and then for some reason they think that they can pull 2 out, yes? Okay, so this is also not correct. Be careful if you are willing to do this in the future, write it somewhere and cross it with some red line that you're not allowed to use them. Why is that? Because the people think in this way. If I ask you what is another name for 2x, it means x plus x, yes? If I were allowed to move sine in, then of course you are right. Then if I could write sine x plus sine x, on the one hand, this is sine 2x. On the other hand, this is sine x plus sine x, which is 2 sine x. Then, of course, in that situation, yes, this was correct. But just right now, we realize that it is not allowed to do something like this. So that's also totally wrong. Yes? Okay. So now let us start writing the formula. So the first thing I want to talk, even though I started my example from sine, the first formula, there are 4 formulas, but one of them, I will write it down here. So if someone asks you, what is cosine alpha minus beta? Okay. The formula is not cosine alpha minus cosine beta. It's more complicated than that. It is cosine alpha times cosine beta, which is not natural at all. It's not trivial at all. So then plus sine alpha sine beta. Yes? So you see that the formula is much more complicated, but this is the correct formula. So we want to motivate why this is the case. Why cosine of alpha minus beta reads like this. First of all, you see that this minus sign is a positive sign here. And this is not just cosine alpha minus cosine beta. It's completely different. Okay, but at least this formula relates the cosine of this angle to the cosine and sine of alpha and beta. Okay, so let us see why this formula is correct. So let me just try to motivate you. So if I draw a unit circle, the unit circle with the coordinate systems, Yes, so for example, let us consider alpha is a trigonometric angle. Let us say that this is alpha. Let me choose different colors here. So for example, let us assume that this angle is beta. Okay, I don't know. Let us assume that this angle from here to here is alpha. Okay, and then I have a point A here and a point B here. And let us take the origin as O as usual. Yes? Because I have two angles. I don't know, you just draw two angles. Let us say one of them ends here, the other one ends there. Okay, so can you tell me what is this angle now? What is this angle? Alpha minus beta, yes? Because from here to here is alpha. From here to here is beta. If I ask you what is this orange angle, the difference between them, yes? So this angle is just alpha minus beta, yes? Okay, now let me ask you another question. If I ask you to read the coordinates of this point, what do you say? This is the final point, this is the end point of this angle. So what are the coordinates? The first one is cosine beta, the second one is sine beta. If I ask you the same question for B, the x-coordinate is what? The x-coordinate is cosine alpha, and this is cosine alpha, and what? Sine alpha. So is that clear? This is something simple, yes? Okay, now let us just do this. I connect this point to that point, and I call it D, the distance between them. So if someone asks you what D is the distance from A to B. Okay, but do you hopefully remember the distance formula? I have 2 points, one of them A with these coordinates, one of them B with these coordinates. I want to calculate the distance between these 2 points. That's the distance formula. So let me remind you. So what was that formula? The distance formula in Math 2C, if you remember, was a square root. The difference between x coordinates squared, yes, plus the difference between y coordinates squared. Yeah, so that's the distance formula. So if I ask you to calculate this distance, what do you say? This distance is equal to square root of the difference between x coordinates. So say cosine alpha minus cosine beta. By the way, the order doesn't matter because I have a power of 2. If I switch, I pick up a minus sign, but that minus sign is canceled because of an even power. So you don't need to be sensitive in the order in which you write them, yes? And then the difference between y coordinates squared. So don't need to be worried about why I am doing this. You need to follow the logic. The person who actually discovered this formula in the first place did these things. I'm just reviewing those, okay? Okay, but now we can continue this a little bit because I can simplify it a little bit more. So I can put this square root here. I raise it to power 2 according to the formulas that we know. So this is cosine alpha squared, 2 times the first one times the second one. Yes. Plus the second one squared. This is just the expansion of the first one. I can continue with the second one. So this one squared is the first one squared minus 2 times the first one times the second one. Yes, and then the second one squared. Yes, is that clear? But can I simplify this a little bit more? How? I hope that these combinations are familiar, yes? I can take this one with which one? Sine. And it gives me what? Cosine of the angle squared plus sine of the same angle squared becomes 1. And the same story for this one and the last one, yes? So I get a 1 from these two. I get another 1 from these two. So if I combine them, it becomes a 2. Yes? So it becomes a 2. And I have a 2 here. I also have a 2 here. So let me just factor a 2 out. Yes? So this becomes the square root of. Yes?
You have written cosine power 2 to the last one.
Oh, okay. Thank you very much. Thank you. Yeah, that's very good that you fixed it. Yes. Just please tell me if you see some mistakes. So the second one is sine. Thank you. I don't know. I didn't realize. Everything else is correct? Yes. That is also wrong. Sorry. Okay, so let us review. This 1 to power 2. The first one is squared. 2 times the first one times the second one. The second one is squared. That's right. The first one is squared. 2 times the first one times the second one. The second. Yes, that's correct. So from this one and that one becomes 1. And this one and that one becomes 1. It becomes 2. I have a 2 and a 2 here and a 2 here. I factor a 2 out. Okay? So what is left for me? So let me not do it. Okay, so let us write it in front of you. So 1 plus 1 is 2. But only between this one and this one, I factor a minus 2 out. So what happens? It becomes cosine alpha, cosine beta, plus sine alpha, sine beta. Yes? Is that right? At least it is promising. You see why? Because the same combination somehow appeared here. Okay, so it is useful apparently. Is that clear? Now what I do, this is d. I want to get rid of this big square root sign, so I raise it to power 2. So this becomes d squared, and I get rid of that big square root sign. I will register it here for future. Okay, so d squared is equal to 2 minus 2 times cosine alpha, cosine beta, plus sine alpha, sine beta. Yes, and then I can keep it in a box because I will need it shortly. So I will call it number 1. Okay, this was very trivial, yes? You might say why this is useful. You need to be patient and see why it works. But then some of you told me that you didn't study the last chapter in Math 3C. There was a theorem there. It's called cosine rule. So I just explained it. You don't need more than this, what I explained here. So just a recap. So let me write it here. If you haven't seen these formulas before, I want to explain it here for you. So if you have a triangle, any triangle, not just a right angle triangle. So you know that if you have a right angle triangle, if this is 90, and if this length is b, this length is c, and this length is a, of course you know that a squared is equal to b squared plus c squared. Okay, that the question was, what happens if this is not 90? Can I find another formula if this is not 90? And the answer was yes. So that is called the cosine rule. So for example, if I have this scenario, which is not 90, this angle is not 90, and if this is B and this is C and this is A, so let me write it here, B, C, A, and this angle could be 90, but this also works if it is not 90. In that case, if someone asks you what is A squared, you can say it is still B squared plus C squared, but minus 2 times B times C times cosine A. Okay? So that is in Math 3C, the last chapter. So you don't need to be worried about uni, but of course in Math 3C we prove this formula, why you should expect such a formula for any triangle. But except for that, it is not important. This is the message. If you have a triangle, this formula is the generalized form of the Pythagoras theorem. Pythagoras theorem is only working in right angle triangles, but this formula is valid in all triangles, including right angle triangles. Why? Because if this is 90, then it becomes cosine of 90 degrees, but cosine of 90 degrees is 0, and this is cancelled, you get the Pythagoras theorem. Okay? So this is something, a formula. So I don't have time to go through the proof of this formula. You can check some of my previous videos if you want to, but this is the message. Okay? And then of course, how can I read this? It means that if I am interested in the square of the side, like a square, I can add the squares of the other sides minus 2 times those sides BC multiplied by cosine of which angle, because there are 3 angles, we choose the angle which is contained between those 2 sides. Okay, so that is the formula of cosine rule. Okay, so now I want to calculate, so you forget about everything I have done so far, but now I want you to calculate for me d based on this theorem. So you can see that this triangle is now upside down. I want to find the distance d. I want to find the length of this dotted line using the cosine rule. Okay, so what can I do? Can you tell me now? The formula is in front of you. So on the other hand, using the cosine rule, in the triangle OAB, we have, okay, I want to wait for you, okay? So what can I write? I want to calculate d squared, okay? Can you visualize the same picture turned over and match it here and tell me what should I do? So what should I write for d squared? What? Yes?
2 plus 2 times beta
Minus.
minus 2 times 2 cosine alpha.
No. So what was the message? If you are interested in the square of a side, in this case I am interested in the square of this side, d squared. This is equal to the sum of the squares of the other ones. Yes? So what is this? Means this one to the power of 2 plus this one to the power of 2. That is why you said 2. Yes? So why this is, what is the length here? 1, because this is the unit circle. So it becomes 1 squared plus what? 1 squared. Yes? Minus what? 2 times 1 times 1 times cosine. This was your mistake only. You said alpha or something. What is that angle now? Cosine of which angle? The angle which is contained between these 2 lines, which is alpha minus beta. Yes? So this becomes cosine alpha minus beta. Do you agree with that? Okay, so let us simplify things a little bit. So d squared is 1 squared plus 1 squared is 2. 2 times 1 times 1 is just 2. Cosine alpha minus beta. Yes? So this is number 2. Okay? But what do you expect? I have done everything correctly based on the different rules of mathematics. Once I used the distance formula to calculate d2. That is one theorem, which is coming from the Pythagoras theorem. Then I calculated the same distance to the power of 2 using the cosine rule formula. But what do you expect? Yes? They have to be equal, yes? Because I have calculated the same quantity, d squared, in 2 different ways. So it means that the results should match, otherwise I will be in trouble. So if I compare number 1 and number 2, so what can I conclude then? I can conclude this quantity, which is equal to d squared, yes, is equal to this quantity, which is also equal to d squared. Because I have 2 quantities equal to the same quantity, I can conclude that these 2 have to be equal, yes? And I hope that you see the proof is done, yes? So this is common. Okay, and why this is enough? Because these 2 and that 2 are cancelled. A minus 2 is left here. Also a minus 2 is left there. After I cancel the first 2's, I can divide everything by minus 2 and then I have my formula. Yes, can you see that? So I divide by minus 2, then it becomes cosine alpha, cosine beta plus sine alpha sine beta is equal to cosine alpha minus beta. This you find it in formula sheet. Instead of alpha and beta, they have used u and v. Of course, it doesn't matter. Okay, so do you see that this was not trivial? So if you just naively do what I explained in the beginning, that is totally wrong. Is that understandable? Okay, and I told you that you don't, I just, because when I teach, I want to, because I could have written the formula, that this is soulless, yes? You need to understand what is going on. Okay, but then you now understand that, then what you really need is know how to use the formula. And the formulas are also in front of you. Okay, so but this is only one of the 4 formulas. Okay, what is the next natural question? I answered this question for alpha minus beta. I should ask the same question for what happens with cosine alpha plus beta. It's a natural question to ask, yes? Either it's so hard we cannot solve it, or we solve it. Yes, this is the way that mathematicians think, okay? When they say that, okay, I have a formula for minus sign, they will ask themselves, okay, why not for the positive sign? Let us see what happens, okay? But the positive sign, the good news is that I really don't need to go to this mess. If you are a little bit smart and you have already learned what I told you, it's a matter of seconds to understand what happens for plus alpha, plus beta. So can you say what happens? This is also a trick. If you don't know, let me write it here. We have enough space. So my question is that I want a similar formula, but instead of having alpha minus beta, I want to have alpha plus beta. Okay. What do you think I will do now? Okay, so then I have to go through all those calculations once more, which I don't want to do that. But any sum, forget about this, Math 1C. If you have a plus b, you can view it as a sum, but if you want to, you can also view it as a difference. Yes? So these are very standard ways of thinking in mathematics. Okay, these simple phrases I mentioned here, I really want you to remember. They're not hard. If I insist to write this expression in a way that instead of plus sign you have minus sign, what do you write? Yes?
Minus A minus B.
No, minus A minus B is not this, is it? You change the problem. I want to tell me something which is equal to this, but instead of having the sign positive between them, I want to have a minus sign, yes?
You have A minus B.
Yes. So any sum can be seen as this, yes? So any sum is actually also a difference, but it is sum of A and B, but this is the difference of A and minus B. So now what I do here, even though this is written as a sum, I can view it if I want to as a difference. So what I can do, I can write as cosine alpha minus beta. No one can criticize that, yes? Because alpha plus beta and alpha minus beta are exactly the same angles. And this definitely the cosines are also the same. But why do you think I did that? Yes?
So you can take the previous cosine alpha, cosine beta, and switch out beta with
Minus beta. So you see that I have a formula for the difference, but this now I can give the role, let us say B to this. So instead of minus beta in my head, I imagine it is a new angle. So this is cosine alpha plus beta on the one hand is equal to A minus alpha minus B. Yes, is that understandable? And now what happened, I don't need to do everything from scratch again. I reduced my new problem to a problem that I already know how to solve. Okay, so that is a very important trick in mathematics. So what can I do here? I say cosine, and again, what is the message behind that? Read it in English. Do you remember every formula I write, there is a message to it. And what the message is here? This one.
The cosine of one angle minus another angle
Hmm?
is the same as the cosine of the first angle times the cosine of the second angle plus sine.
Exactly. So the cosine of the difference of two angles is the cosine of the first one times the cosine of the second one plus the sine of the first one times the second one. This is the message behind this formula, and it doesn't matter what is the name of the first angle, what is the name of the second angle. Now what I have here, I have cosine of the difference of two angles. One angle is alpha, another angle is called capital B, but who cares, yes? This is the cosine of the difference of two angles. What can I write here now? It becomes what? It becomes cosine according to the message behind the formula. Cosine of the first one multiplied by cosine of the second one. What is the second one here? Capital E. And then plus sine of the first one and sine of the second one. Yes? Is that right? I am just using the same formula. I told you that this is a formula that has a message. I just read that message to myself again for alpha and B, and I got this. Is that right? But B is something I brought in. It was not there in the beginning, so I have to switch back. Yes? So what happens now? It becomes, what is capital B? What is capital B? What is capital B is minus beta. And then plus sine alpha, sine minus beta. Yes? Is that understandable? Yes or no? Okay. And then what? You don't have any clue. That is the role of the memory. I don't know how to fix it. Because so you think that having the formula sheet is the same thing as having the formula somehow in your head. They are not the same, you see that. Because if it doesn't look, if there is nothing familiar to your eyes, then you even don't bother. This is a neurological problem. You don't even bother to look to the formula sheet because you think that this is something that I don't understand. You even don't recognize that's the formula that you don't know. I don't know how to fix it. It's a real big problem, okay? Yes. So I don't know how many of you recognize I said something about this combination. Yes or no? Do you remember what was the topic? What was the topic? Yes?
It's when you have minus an angle, the relationship between cosine of a negative angle
And cosine of the angle, which I titled it for being easy to reference it, the trigonometry of opposite angles. Yes, beta and minus beta are opposite angles. One of them is more positive, the other one is negative. So if you don't remember this, you get stuck at this stage. And then I don't know, the only role that I have as a teacher to warn you, to draw your attention to this. Okay, so mathematics learning is based on these kind of things. So if you don't remember it, that's a dead end. Okay, so it doesn't mean that you don't understand mathematics. It means that you understood mathematics quite well, and then you forget it. Okay, so that's a difference. Okay, anyway, so how many of you remember cosine? Because you know that if you don't remember this formula, you have to be creative enough to find all these formulas from scratch, and it is possible, by the way. It's not hard because then what do? You say that this is my angle beta minus beta. I already know it is here. So how cosines are related? Cosines are the x-coordinates, so they are exactly the same. How sines are related? Sines are y-coordinates, so they are opposites. Okay, so either you have to be creative and fast enough to do that, or at some point you need to remember at least something. Okay, so anyway, I can continue this. So this becomes cosine alpha. So do you remember what was cosine of minus beta? It was exactly cosine of beta itself. But what was sine minus beta? Minus sign goes out, so it's minus sine beta. But then this is positive multiplied by negative, so it becomes negative, yes? Okay? So now this will be my second formula that I will write it here for you. So if you don't mind, let me write all the formulas here. So the number 1 was cosine alpha minus beta. It becomes cosine alpha cosine beta plus sine alpha sine beta. Yes. And then the second formula is cosine alpha plus beta is what? Cosine alpha cosine beta minus sine alpha sine beta. Yes? So if you have cosine, you have cosine cosine, sine sine, and the sign between them is exactly opposite. If it is minus, it is plus. If it is plus, it's minus. You don't need to remember these details because the formulas are there. So these are the two formulas. So what I will teach you next? Sine, yes? Because I want you to be see that, okay, you are expecting that I give you, you are dying for it, yes? Crying out, okay, Bob, please give up the formula for sine. You have to have this attitude, otherwise it doesn't make sense to be in math lesson, yes? So the next formula, I want to say the same questions for alpha minus beta for sine and alpha plus beta for sine. Okay? So what is your suggestion now?
Just guess if you can switch to sine times sine and cosine times cosine. So you start with sine alpha sine beta plus cosine alpha cosine beta.
But how did you come up with this conclusion?
That's just a guess.
No, guess is not good. Guess is good. That's an intuition. Usually mathematicians have intuitions about what to do, but that's not an argument anyway. Okay. So what do you do now? Yes?
We'll just do the similar thing with cosine.
No, similar thing, you can immediately see that we will be in trouble because unfortunately this formula, the proof that I did similarly, depends heavily on this rule. And this rule only works for cosine. You're not allowed to change it to sine. So it doesn't work. So what I'm going to do? Yeah, press your brain a little bit, okay? What should I do now? Okay, let me explain it in this language. Might be this language hopefully seems familiar to you. I want to say something about sine, yes, of alpha minus beta. Do I know something about cosine of alpha minus beta or not? Yes or no?
Yes.
Because I know it, yes? So I want to say something about sine of alpha minus beta, but I know something about cosine of alpha minus beta. Is this sentence ring a bell? Something? Yes? Nothing? Okay, again, that's a memory problem, you see. Yes?
This is just a guess, but if you square sine plus sine.
No, you cannot square it. You want to say something about this this entity, you cannot square it. If you square it, you're talking about square of that thing. Okay, listen to me. Okay? So we know something about cosine of an angle. Yes? We want to say something about sine of that angle. Yes?
I have a question. If we know that cosine of an angle equals sine 90 minus an angle, why can't we just put it into that?
Yeah, exactly. That is the reason. So that was, I told you several times, how many times we have the trigonometry of complementary angles. Okay, so you need to trust me on that, yes? So I want to know something about sine of an angle, but I already know cosine of an angle. Okay, so what I do, might be this is hard. I'm not saying this is always working, but this is something that you need to come up with first. So instead of sine alpha minus beta, I can write what? I can write cosine, but help me to write it. Cosine of which angle? The complement of that, yes? The complement, sorry, the complement of that. It is 90 degrees minus alpha minus beta. Okay, to be honest, how many of you could understand this if I didn't explain this before? Do you understand that? If I just write this and I ask you true or false, could you recognize that this is the same thing? Yes? Okay, so you know that alpha minus beta and this angle, how many of you doubt that this angle and this angle are complementary? Understand that or not? Because, why? Because if I take and add it to this one, this part and that part are cancelled, 90 degrees is left. Okay? Is that right? Okay, now what happens? There is some unfortunate problem here. What is that unfortunate? Let me multiply this minus sign in. It becomes minus alpha plus beta. Okay? But then do you think that I have a problem now? Why? Of course, I was able to change sine to cosine, but the price I paid was that what? The formula for cosine talks about how many angles? 2 angles. But when I did that, how many angles actually appear? 3. One of them is 90 degrees, one of them is minus alpha, one of them is plus beta. Okay, either you have to give up, meaning that this is not a good strategy, or you need to modify that. Do you think there is a way that I can modify it? If yes, we do it. If no, we throw it away and then we have to do something else. So do you understand what the problem is? I was able to change sine to cosine with the hope that I want to use the first formula, but unfortunately the first formula, what has it? It has 2 angles and minus sign between them. Of course, can I use the second formula now? Yes, but I need 2 angles again with the sum between them. Okay, what can I do now? Yes? Yes, you can cancel, you can consider it 1 angle. Okay? So you can say that, okay, every 3 numbers, so these are very simple tricks in mathematics. This is the sum of 3 numbers. Can I view it as the sum of 2 numbers? Yes. For example, I can consider a plus b as 1 number and c as another number. So in principle, again, this is the sum of 3 numbers, but it can be viewed as sum of 2 numbers. One is a plus b, the other one is c. So what I do, I will do the same thing here. So I will take this angle, let me call it capital A. Yes? So then how many angles are involved? 2 angles. One of them is capital A, the other one is beta, and the operation between them is addition. So which one is useful here? Second. Yes? So it becomes, now read it. It becomes what? Cosine of the sum of 2 angles is equal to cosine of the first one times cosine of the second one. Yes? Minus sine of the first one, sine of the second one. Everyone understands what's going on? Okay, then I have to switch back to my original variable, yes? Because a was something that I brought in. It was not in the problem from the beginning. I brought it in because I want to understand it better, and after it serves the purpose, I just get rid of it. So it means that instead of a, I substitute what? 90 degrees minus alpha, and then I have cosine beta, and then I have minus sine 90 degrees minus alpha, and then I have sine beta. Yes? Okay, but does this look familiar? What is that? Cosine of 90 degrees minus alpha, hopefully what is the answer? Sine alpha. So this becomes sine alpha times cosine beta, and then this becomes cosine alpha sine beta. And that is my formula, so I will write it here. So this becomes sine alpha cosine beta minus sine beta cosine alpha. Yes? Okay, so what is the message? The message is that the sine of the difference of 2 angles is sine of the first one multiplied by cosine of the other one minus the other way around. Yes? Okay, and then hopefully you know what to do. Can you predict what will happen here? What is the answer? What do you think I will write? So alpha plus beta, you can view it as alpha minus beta. So this is your first angle. This is your second angle. So what happens? It becomes the sine of the first angle, cosine of the second angle. But cosine of minus beta is again cosine of beta. Yes? Minus sine of the second angle. Sine of minus beta is minus sine beta. So this minus sign becomes positive. Okay, so these are the four formulas under the title of addition and subtraction formulas. Okay? In principle, what I should teach you next? Tangent. But tangent, for some reason, in Swedish syllabus, it is not there, so you don't need to know about that. But it doesn't mean it is a big problem. You can find it yourself, okay? And the reason is somehow good, you know, because if you know about sine alpha plus beta, and you also know about cosine alpha plus beta, and then you can divide them, it gives you tangent alpha plus beta. Might be that was the reason that they didn't want to talk about it, okay? But you can find a different formula for that. But any questions here? Understandable? Okay, so you can say that if that was heavy for you, don't be scared. You can forget everything I said. I don't recommend that, because then I don't know what is the purpose of reading mathematics, yes? Anyway, but if you don't like these kind of things, these are the formulas. And then we want to learn how to use the formulas, which will be good for the exam, okay? Any questions so far? But do you understand that is what we did? Yes, if someone asks you what we did today's lesson, we say that we discovered four formulas of how to expand. You see, expand means writing something without pair of brackets. So we learned that if I have cosine of a pair of brackets with alpha minus beta, how to expand that. Yes, in terms of the angles alpha and beta. Yes. Okay, let us just choose some problems in the book. So they have asked you to expand and simplify this expression. Okay, so let me write example. Expand and simplify. This is E-level question, okay? Simplify sine of x minus 30 degrees. Yes? Okay, so you already know what to do, hopefully, yes? I want you to see that, because you know that when I give an example, that's also a very big danger, yes? Because when I am teaching this, you know that the example that I am talking about is relevant to what I taught right now. But the point is that you need to understand when in May you see a question. So you need to realize this question is related to today's lesson. So you should have a deeper understanding. Why do you think this is related to today's lesson? Because you want to calculate sine of the difference of two angles. And if you read the English message behind the formulas, you understand that this is the relevant lesson. Yes? Is that right? Okay. So what can I do now? The solution, I would say that sine of x minus 30 degrees. Which one of the formulas, 1, 2, 3, or 4, is suitable to do this? Which formula? Number 3. Yes? Alpha is being played by x. Beta is being played by 30 degrees. Yes? So what I need to do is just copy and paste the formula. So I read it in that way. Sine of the difference of two angles is sine of the first one multiplied by cosine of the second one minus the other way around. What does it mean? It means sine of the second one multiplied by cosine of the first one. This is today's lesson. The rest of it is the previous lesson. What is the rest of it? Of course, you need to remember that 30 degrees is famous, so then you go to the table, we can read this number from the table. But I have it in my memory, so this number is square root of 3 over 2, and then I have this one in my memory as well, and this is 1/2. Okay, so what you write, in principle, if you have a number, you can write it here, but it is more appropriate to start with that number. So I prefer to write this. And this is minus 1/2 cosine x. So yes, so that's it. That is an E-level question. You stop here. But again, don't write please sine x minus sine 30. You see that is not correct. Okay? Okay. So do you remember what was the complementary formula? So do you remember we have the complementary angle formula? We just used it. Okay? Use this lesson to show that. Use this lesson to show that. For example, let me write cosine of 90 degrees minus alpha is equal to, you already know the answer. What is the answer? It's sine alpha, yes? But I want to use this new lesson to rediscover the same formula that we already knew, yes? So can I do that? Is it relevant to this lesson now? Yes or no? Hello? Yes or no? Yeah, be active a little bit. What has happened, you know? You are young, yes? You have to be energetic, yes? Yes. Okay, anyway. So cosine of 90 degrees minus alpha is today's lesson. Because I have a cosine of the difference of two angles, and we learned that. Even though this was something that we could also discover with very basic principles when we started the lesson. But we can rediscover it again. If I want to rediscover it again, I want to prove equality. When I want to prove equality, I have to start from one side and continue to the other side, yes? So what I do this here, I would say that the left-hand side is equal to, let me copy and paste the left-hand side in front of my eyes. Okay. Now, can you immediately see that one of these formulas can be used? Which one? Number one. Yes? So read it. The cosine of the difference is the cosine of the first one. Yes? Times cosine of the second one. Plus, if you see the formula number one, plus sines. The same combination for sines. Yes? Do you agree? This is today's lesson. But now this is also hopefully famous. Cosine 90 degrees, you can visualize it. Cosine is which? Cosine of 90 degrees, everyone. 0. Sine of degree, sine of 90? 1. So 0, so this let me write it in front of your eyes. Okay, but then what happens? This combination is what? 0. So I don't write it, it's 0. And then I have 1 times sine, which is only sine. And that is exactly equal to the right-hand side. So this is another way to find the same formula that we already know. Okay, so that's a good idea. So you can always use this if you don't like it. Okay, so let me test your understanding. Can you understand this formula using this lesson? It is less trivial. So what is the formula? You already know, hopefully. Sine of minus alpha is equal to? Minus sine alpha. Do you think this new lesson is also good to discover this again, to rediscover this again? Not that directly, yes? Because in these formulas, how many angles are involved? 2. So can you somehow be a little bit smarter, more creative, to see that how can I use this idea to reprove this formula? Yes? Alpha minus 2 alpha. That's a good idea, but it doesn't work. Do you know why? Because we don't know anything about 2 alpha yet. So it becomes sine of 2 alpha. Okay, so what can I write for it? Yes? 0 minus alpha. Yes? So what can I do? I can start from the left-hand side. Instead of sine, this is sine minus alpha. But I can view it as what? 0 minus alpha. Do you agree? 0 minus alpha and minus alpha are the same. So which formula is now useful? Number 3. So this becomes sine of 0 cosine of alpha minus sine of alpha cosine of 0. But what is sine of 0 degrees? 0. What is cosine of 0 degrees? 1. And then this is gone. It becomes minus sine alpha. Okay? So you are also discovering the same formula using the same idea. But here you have to be a little bit more creative to understand how can I write minus alpha. Okay? So this is the way that you need to learn. Okay. So I use the example in the book, but I change it a little bit. So I would say that exactly like this. I would say expand and simplify. The books has ask you to prove something. Okay, so I want to wait for you. Expand and simplify. Okay, what is that? It is cosine 3x plus 180 degrees. Okay, I want to wait for you. The formulas are in front of you, yes? Okay, after doing that, this is a level 1 problem in your book. I want you to do this. Yes? Both of them. It is good about that one of them is based on degrees, the other one is based on radians. And keep it exact, because 110 degrees is not a famous angle. So whenever you face it, just keep it like this, okay? Of course, if you want, you can put it in the calculator. Okay, so we do like this. If you understood what it's supposed to do, I will explain it there. If you really know what is going on, don't listen to me and do this one, okay? Don't waste the time. Okay, so here, which formula is useful? Let me repeat this if you don't have it. So you see that I have cosine of the sum of two angles. And the second formula is suitable here to use. So what I will do, I will take that so solution is this. Cosine of 3x plus 180 degrees. I give the role of alpha to the whole combination here, and I give the role of beta to this angle. And then I use the second formula here, yes? So it becomes cosine of the first one, cosine of 3x. Okay, that's it. Don't pull 3 out. We don't have such a rule yet. And then times cosine of beta, which is 180 degrees. But this sign is positive. You see that in the second formula, if this is positive, this is negative. So this becomes negative. The same combination, but instead of cosine, we have sine. Then hopefully you realize that this angle is some famous angle, and then if you check it in the table, cosine of this is -1, and sine of that is 0. This information you can get it from the formula sheet. Okay, and then -1 times that, it becomes simply cosine 3x, and 0 times this is 0. I want to subtract. Okay, that's it. So the answer becomes minus cosine 3x. And this is the end. You have to stop. Yes? Is that understandable? Okay, this is also the same thing, but you have to use two formulas now. But be patient, that's not hard. I just wait for you. So 2, 2, 3, 4. I think this is level 1. Let me see. Yes, it is level 1 problem, and it really deserves a level 1 problem. So I have written just simplify. Yes, because there is nothing we can do right away. We can open it up using these formulas that hopefully you can see and see what happens. At least the first one for you. So you see, in expanding and simplifying this, two formulas are involved, yes? Which ones? Number 3 and number 4, yes? Number 4 for the first term, because I have a positive sign. Number 3 for this one. So what I do, if I want to simplify that, so A is equal to, So what should I write? The formula is in front of you, yes? Sine of the sum of two angles is the sine of the first one. Oops, it's x. Sine of the first one times cosine of the second one. Yes? But plus the other way around. Sine of the second one, cosine of the first one. This is the expansion of the first one. Yes? But what is the expansion of the second one? Exactly the same combination. Look here. The difference between these two formulas is just because of this minus sign and plus sign. So that's, I copy and paste, but I have to remember to switch these to minus sign. So this becomes sine of x cosine of 110 minus sine of 110 cosine of x. Yes? Any questions here? Okay, how can I go further? Because I hope that you understand that 110 degrees is not a famous angle, so there's no point to go to the formula sheet. So, but we can simplify a little bit more, yes? Because this term and that term, whatever they are opposite. They are coming with different signs. They cancel. And these two terms are exactly the same. So if you have the same quantity added to itself, what can I write? 2 cosine 100, or the other way around, doesn't matter. 2 cosine 100 and sine x. This is what I expect you to stop if they ask you to do this. If I want you to continue further, probably I will give you access to the calculator and I will ask you, for example, do it into decimal point or something. Then you punch this part in the calculator and write it there. Yes?
To put it in the bracket.
No. But here you don't need to put it in brackets because multiplication doesn't need brackets. What do you mean? I have to remove this pair of brackets first, and then nothing happens because this is a positive sign. This is the reason that I changed this to negative, because I want to, let me solve this one as well, okay? So that might be you understand what is happening. So for part B, what I'm supposed to do, which formulas are useful? 1 and 2. So I open a pair here, and then you see I want to write the answer to this one inside here, but then after that I have a minus sign, and then I open another pair of brackets. I want to write the answer here. In the previous case, it was just a matter of taste if you want to put pair of brackets or not, because the sign was positive. So even if you don't do that, it doesn't matter. But here it is important, or you have to calculate it in your head. Okay, the second formula is useful for this one. The cosine of the sum of two angles is the cosine of the first one times cosine of the second one. Yes? Minus sine of the first one, sine of the second one. Yes? And then the second one is the same thing, but you have to switch it to a plus sign. So this becomes cosine x, cosine 3 pi over 5, and then I have plus sine x, sine 3 pi over 5. Yes? But let me be patient. I have to remove the pair of brackets. I was lazy to do that there because it was very simple. Okay, but here I remove it because there is no sign behind that, so I don't need to be worried at all. Yes? I'm just copy and pasting. But this one I have to be careful. When I want to remove that, because there is a minus sign behind that, this minus sign is also another common mistake. People usually put it only for the first one. But this minus sign is not only for the first one, but also for the second one. So this becomes minus cosine x. Why is that? Because minus a plus b, if I ask you to open up the pair of brackets, if you write it like this, that is wrong. The correct one is this. Yes? Okay, so that's the same story here. So this goes there. Yes? Yes? And then, can I simplify more? Can I? Yes, because whatever this term is, that is the same term with the opposite sign. So this one and that one are cancelled. But these are not cancelled. What can I write? These are not cancelled. What can I write instead?
Minus 2 times.
Minus 2, because I have, so you see I have minus a quantity. This is your quantity. And again, you have minus the same quantity. What do you write? You write minus 2 of that quantity. Yes? That's the same story. So it becomes minus 2 cosine x cosine 3 pi over 5. So when I want to solve it exactly, this is the end. But if I ask you to do some approximations using calculator, you have to be careful. You have to switch to radian mode and then put it in the calculator. Okay, any questions so far? Yes? Oh, thank you very much. Yes, thank you very much. Yeah, that's the same thing, this quantity, 2 times. Thank you very much. Okay, so this is the end of the story here. Okay, now let us test your understanding again. Do you think now we have everything at our disposal to say something about sine of 2x? If I insist you to find the formula for sine 2x, do you think we can do it now? Again, I hope that you understand that inventing new formulas is actually very good. If you want to discover new formulas, I encourage you to do that, but not any formula that you desire, okay? So if you are tempting to write this, you have to have a good reason. So because you are saying something, you are saying that if there is a multiple inside sign, I can pull it out. So you are inventing a rule, okay? So you have to invent the correct rules. Okay, some of you might think this is true or false, but do you think we can discover the correct formula at least right now? I want to discover a formula which I can rely on for sine 2x. Yes?
Can't you write sine 2x as sine 2x minus 0 and then find the formula?
No, okay, let us do that, but this is not something, this is not doing something for you. Because it will give you sine 2x back. So it gives you sine the first one, yes, cosine of the other one, minus sine of the other one, cosine of the first one, yes? And if I ask you what is cosine 0, it gives you 1. What is sine 0? It is 0. And then what is the answer? The answer becomes exactly sine 2x again. It is not a wrong thing, but it is something that I already knew, that sine 2x is equal to itself. Yes, please. Pardon? Plus x. Very good, very good. So you see that because this lesson, if I want to use this lesson, how many angles I need? 2 angles added or subtracted. Then it might motivate you. Can I write this as a sum of 2 angles? Very simple, yes? What can I do? I can write it as sine of x plus x. Now hopefully you realize which formula is useful. Which formula? Number 4. I give the role of alpha to x. I give the role of beta to x again. So read the formula. It becomes sine of the first one, which is x, cosine of the second one, which is also x in this case, plus the other way around, sine of the second one, cosine of the first one. Do you agree? That's the expansion. But can I write it more compactly? What? What can I write for it? Yes? 2, yes? Because this is the quantity plus the same quantity. It becomes 2 times that quantity, yes? Okay, so we add something to our formula today, okay? Double angle formulas. Number 1, yes? So sine 2x is equal to what? 2 sine x cosine x. Again, this is a formula. Forget about the formula. What is the message of the formula? This is important. So what is the message of this formula? Yes, just quickly, please. What is the message? It doesn't have any message for you. Yes? It's called double angle formula. So sine of 2 times an angle is 2 times sine of the angle times cosine of the angle. Okay? What will I teach you next? cosine of the double angle. Yes? So I want you to be in track. So this is natural. You know about cosine of 2x. It is natural to ask, okay, is there any formula for cosine 2x as well? Okay? But before teaching you that formula, let me tell you how many of you agree with me. If you see this in front of you, do you accept it as a truth or as a lie? So how many of you agree with this one now? True or false? Okay, let me ask you one question. The way that I read it was reading it from left to right. Every formula can also be read from right to left. Okay? From left to right, I read it for you. Can you read it from right to left? Read it quickly. Yes?
Times the sine of an angle times the cosine of an angle.
2 times sine an angle times cosine of the same angle is equal to
To the sine of 2 times the angle.
2 times the angle. Okay, so now, is that combination the same combination here? I have a 2, I have sine of an angle. The name is not that name. It is x over 2, but the point is that x over 2 appears here and there. So 2 times sine of an angle, cosine of an angle, according to this rule, is sine of 2 times of that angle. But that 2 times of that angle is what? X. So you can write sine x, even though it is ridiculous because sine x is already better for us, more familiar. We have written it in a more complicated way. But believe me, if you are solving hard problems, this is sometimes needed. Okay, so for example, how many of you agree with this one? Is that right or wrong? That's the same thing. True or false? Yes? 2 times sine of an angle times cosine of the angle is sine of the double angle. But 3 alpha over 4 times 2 becomes 3 alpha over 2. Yes? So now from now on, so you need to know more people in the world of trigonometry. This combination sine cosine is famous. Okay? Whenever you see sine cosine with the same angle, you need to remind yourself, might be this is the trick. So you remember what are the famous combinations? Sine alpha squared plus cosine alpha squared. This is a famous combination. The answer is always 1. And there is another famous combination, 1 minus cosine alpha squared. What's the answer to this? This combination should look familiar to your eyes. So what is the answer? Sine alpha squared. And then the other famous combination is what? Yes, it is sine squared alpha. So this is one famous one, the second famous one, the first one was the identity. Now these combinations that you have these kind of things, and these combinations should look familiar, okay? Well, when the lesson ends, do you know? Okay, so then let us do the natural thing again. So can you help me to do the next one? Double angle formula. So what can I write here for cosine of 2x? Let us discover. If you don't mind, let me clean this. So again, you know what I'm going to do. Instead of 2x, I will write what? X plus x. So it becomes cosine x plus x. And then which formula is useful? The second one. So it becomes cosine of the first one, cosine of the second one, minus the sine of the first one, sine of the second one, yes? So this becomes what? Cosine x to the power of 2 minus sine x to the power of 2, yes? So I can write it here. So you see how much difference is there. If you just put 2 out, it is completely off track. It's not at all. Again, the good news is that that's also a famous combination. It is a little tricky, be careful. Cosine x squared plus sine x squared is a famous combination, which is always 1. But the difference, if cosine comes first, is also a famous combination, but it becomes cosine of the double angle. Yes? Is that right? There are 3 formulas here, so I continue this. instead of cosine squared x, I can use the formula here. I can write it as 1 minus sine x squared. With another one, it becomes 1 minus 2 sine x squared. I think there are 3 formulas in the formula sheet. And there is also another formula. I can eliminate this, and I will get this one. Okay? For sine, we have this combination. Now you see, this combination with the 2 is also famous. This combination without 2 is famous, but there is a very big difference. What is the answer to this? Is cosine, 2 is up there, x is here. But if you have 1 minus 2 sine x squared, this is also famous, but 2 is not there, 2 is here. Okay, so it is good to write them somewhere that you can compare them, because this is nothing you don't understand. Exactly, you understood everything right now, but might be next week you forget everything. That is not my problem. Okay, you need to solve that problem yourself. Okay, thank you very much. Just wait a little bit.